All right, getting into our first couple sections of Chapter 11. A large part of this is going to be review, but watch the video all the way through. There's at least definitely the last problem in here you want to make sure that you see with the bearing problem. So a couple reminders here along the way, though. Some basic right triangle trig. So if we have a right triangle, things we can always consider are things like Pythagorean theorem, something you guys are obviously very familiar with. Just the basic use of sine, cosine, and tangent. And you're all familiar with the SOHCAHTOA phrase. And so just, I guess my only reminder on that would just be, remember that that is always in relation to the angle that you are working with. So if this is the angle that I'm going to be using, that makes this the adjacent leg, that makes this the opposite leg. The hypotenuse is always the hypotenuse. And so all that is relevant to the angle that you are working with. So here's just a couple examples, and I feel free to give some of these guys a try, but if it says solve the triangle, that just means find everything that's missing. So in this case, we know two angles, the 22, the 90, and we know one side, which is 46. So they'd always give you three pieces of info. You got to come up with the other three. So all the things that you just saw in up above in part A are all the things that you would use to come up with those angles and sides. So in this case, easiest way to come up with our missing angle would just be to know that, you're right, the three angles of a triangle have to add to 180, so that's an easy way to figure out that this is 68. The shortest way is to recognize that if this angle is 90, then the other two acute angles must also add to the other 90 degrees of this triangle. So if I just did 90 minus 22, I get my third angle, and then now I can just use SOHCAHTOA to get my two missing side lengths. One warning on that would be, at this point, you can either use the 68 or the 22 in order to come up with your two missing sides with SOHCAHTOA. My advice would be to never use your own information. Try to use what was given to you. There's always a chance that you made a mistake on this number. Maybe just simple subtraction, maybe you considered it to be 78 or 58 and just made a careless error. You don't want that to spill over into your other answers too. So try to use what was given to you instead of your own. So in this case where you're given two sides and an angle, obviously we would use Pythagorean theorem to find the third side. Once you get the third side, then we're going to find an angle with SOHCAHTOA. Anytime you are ever trying to find an angle, that is when we use an inverse function. When you're trying to find a side length, we use the regular sine, cosine, and tangent. But if you're looking for an angle, in every case, that's where you use the inverse function like this one. And then always round to 3 sig figs unless the directions say otherwise. So always continue doing that. Special right triangles like a 45-45-90 and a 30-60-90. Couple ways we can use this. One is, right, obviously we know the basic ratios for 45-45-90s. The two legs are always equal. And then if you take a leg and multiply it times the square root of 2, you get the hypotenuse. Obviously you can divide by the square root of 2 to go the other direction with it and get a leg. Same thing with 30-60-90s. When you have your basic 30-60-90 triangle right here, your short leg, which is the one that's always across from 30, is our basic x value, or a value of 1. Your hypotenuse is always twice the size of your short leg. And your long leg is always the short leg times the square root of 3. So if you look at some of the basic scenarios with these special right triangles, if you use things like SOHCAHTOA, for example on this one, if we said the sine of 45, well, sine is opposite over hypotenuse, so 1 over rad 2, which we could rewrite to rationalize the denominator and write it as rad 2 over 2. Well, you guys know from your unit circle, things like the sine of 45 or sine 30 or cosine 30, all the stuff you dealt with in your unit circle. So what some people do is they just memorize the first quadrant of the unit circle, and that really pays off for a lot of what we do. But if you don't remember the first quadrant of the unit circle, then you would just use basic right triangles like this, your special right triangles, to help you come up with those ratios. And so there's going to be a lot of problems in test scenarios where you're dealing with something like the sine of 60, and you just need to know that it's rad 3 over 2. Your calculator doesn't give you answers in radical form like this does, so you need to somehow come up with numbers like this. And so you can either, again, memorize the first quadrant of the unit circle, and that will really pay off for a lot of cases within our test questions. Or if you don't memorize them, again, just fall back on some basic 30, 60, 90 drawings or a 45, 45, 90 drawing in order to help you come up with those ratios. Moving on. So a case like this, again, this would just be another scenario where you would want to come up with the extra sides with use of a 30, 60, 90. You'll notice there's going to be a lot of cases where they ask you for exact values, and that's kind of the way of making you use your knowledge of 30, 60, 90s, because then you have to keep your answer in radical form, and you can't use a calculator for stuff like that to get an exact value if it's going to need a radical. So you do want to make sure that you're familiar with your 30, 60, 90 rules and 45, 45, 90 rules. All right, getting into angle of elevation and depression. The key to elevation and depression is to simply know that they both have to be formed with horizontal lines. And so when you look at a drawing like this, just about everyone recognizes, if I were to just throw out the phrase angle of elevation, everyone seems to be pretty comfortable that this is the angle of elevation. But if we were to throw out the phrase angle of depression, where would you put that? And oftentimes people want to call this the angle of depression, but simply it can't be, because remember, depression and elevation have to be formed with horizontal lines. This angle is formed with a vertical line, so this cannot be the angle of depression. And so what we have to see on this, and let me see if I can get a little drawing in there. Alright, so what we'd have to see is if you could draw a horizontal line right here, straight across. I'm hoping that's showing up for you. But if I could draw a horizontal line right there, and now I could see this angle as my angle of depression, because now it's formed with a horizontal line. In short, what you really need to know is, if you can think back to some basic geometry stuff, and this is going to help you with some other things as well, things like alternate interior angles. So because obviously this horizontal line would be parallel to this horizontal line, that creates alternate interior angles, which are always congruent. So if this is my angle of depression and this is my angle of elevation, what you need to recognize is that they're the same angle. So if I tell you that you have an angle of depression or elevation, as long as you take either one and draw it with a horizontal line, they're always equal. So you can put it anywhere where you have a horizontal line. And so I can call this my angle of elevation technically, or depression, because they're both 75 degrees. Even though I would call this is technically my angle of depression, because it's equal to this, it doesn't matter which one I name within the word problem. They're both the same value, so I could place either statement right there. But anyway, now that you have that, so now if they say cases like this, so observers 120 meters from a building, so there's our 120 meters from the base of the building, angle of elevation is 75, and again, even if they were to say angle of depression was 75, I could still put that here, because as long as I put it with a horizontal line, I'm good. So find the height of the building, so now we can just use our basic right triangle trig to figure that out. So here's one that you need to know, our bearing problems. The key phrase on this, and this is probably the one thing, at least within these notes, that you haven't seen before. Key on this though is that when they give you a bearing is always measured clockwise from the north. That's your key phrase. So clockwise from the north. Because the hardest part about doing these is just being able to come up with your own drawing and labeling values where they should go. So take a look at this one. We got a ship moving from point X, so this is our starting point right here, to point P. So, and if you didn't have this drawing already, this is the drawing you need to be able to come up with on your own. So I'm going to label a point X. I'm going to label some point P, and you might not know where that goes initially, but if it said a bearing of 65 degrees, this is how I would have known where to put point P. I would have said, okay, well, here's X. Let me draw a vertical line, because remember, everything is clockwise from the north. And so you always want vertical lines drawn in order to make your bearing problems. So I would draw a northern line. And if I go approximately 65 degrees clockwise, and so we're estimating that, but do the best that you can to estimate that. So I would see that as about 65 degrees. And so now if I go along that line, somewhere out here in space, I would be putting a point P to create that 65-degree angle that you see here. And so that's the process I would have taken in order to place point P as accurately as I could. Then it says from point P, we're on a bearing of 155 to point Y. And so again, anytime you see the bearing statement, from where you're at, you would draw a vertical line because we're doing this in relationship to the direction of north. And so I got to draw a northern ray that you see here. And I'm going to say, okay, from that northern line, if I can approximate as much as I can 155 degrees, right? Use basic knowledge of, this would be 90 degrees. You know that 180 would have been straight down. And so somewhere in between that is about 155. And so if I just follow somewhere along that ray, that 155 degree ray, somewhere out here I'd be just placing point Y. And then they give us some values on that. So sometimes these drawings are given to you, and some values like this are given. Other times these would just be within the word problem. And so they might have said something like it travels 200 miles from X to point P, and then they would have said then it traveled another 350 miles to Y. And so they would have somehow given these within the problem, and that would help you with the length of your lines as far as how far to place Y and how far to place P. So those things would come up within the problem. But the key on this is proper use of the angles for the bearings. And so as long as you stick with that statement clockwise from the north, this isn't too bad of a drawing. Once you come up with the drawing, it's now basic use of right triangle trig to figure out whatever it is that's missing. And so in this case, it says find the bearing from of point Y from the point X. And so we're now looking for a bearing or an angle to get that done. Sometimes they'll ask for segments. They might say how far are you from Y or to Y from X. So they might ask you some distance questions like that. But in this case, it says find the bearing. So we're looking for some angles on this one. Since this says the bearing of the point Y from point X, so consider here that here's point X. Remember, the bearing is always from the north. And so if I'm starting at point X and I'm going to Y, from the north, so here's my northern line, I'm going from north, and if I travel clockwise until I hit the line that goes to point Y, that's the angle that they're referring to right there. So from this segment right here, formed with the north, is the angle that we're looking for. One we already know this is 65. So a couple other things that we would have to come up with on our own here. Remember that if we have vertical lines right here, right, these are consecutive interior angles and must add to 180. So if that is 65, that must be 115. We already knew that this was 155 from the problem. And so now if we consider this being a circle right here, we know all this would need to add to 360. And so if that's 115 and that's 155, subtract those from 360 and you'd figure out that this is 90 just based on that. And so now that I know this is 90 degrees, that's pretty key because now I have a right triangle. I can use basic right triangle trig to figure out whatever it is I need to know from here. In most bearing problems, they tend to give you a right angle. Not all of them, but that's pretty common. So that's kind of something you look for within the bearing problems. But now that we have all that, it's just now solving a basic right triangle to come up with our missing angle here. So in this case, if we just use one of our inverse functions like the inverse of tangent, so from this angle, this would be opposite over adjacent. So I use inverse tangent to get my missing angle here. And now I can add this to 65 to get the complete angle that they were asking me to find. Go through this once or twice. Make sure you pay attention to these in the homework. This is often a very weak problem for students on a test. And so this is one you definitely want to be familiar with.